All right, we're going to take a look at characteristics of functions, and this section kind of ties together a lot of different things, including a lot of definitions, domain and range, and different things that are going to be happening with our functions. All right, so the first thing here is when you see a function written like this is read f of x equals, and f is just the name of the function. It doesn't have to be an f. It could be an f, a g, an h. It could be any letter that you want it to. And the x right here just happens to be the letter that, or the variable that is going to be in your equation. And a lot of times this function is named according to what type of equation it is. For example, if you have an area of a circle equation where area is equal to pi r squared, a lot of times that would be written a of r is equal to pi r squared. All that means is that the area in terms of r is equal to pi times the radius squared. The x in the parentheses means the x is the variable being used in your equation, and coordinates that are usually written as xy can also be written as x comma f of x. So let's take a look at a specific example here. We have f of x is equal to 2x plus 4, and then it says find f of negative 2. So just recall our problems were written as f of x. That just simply means that your x value is negative 2. So you're going to put negative 2 in everywhere you see an x. So this is going to give you 2 times negative 2 plus 4, which is negative 4 plus 4, or 0. Okay? And then the next one says find f of 3. Well, f of 3 would be 2 times 3 plus 4, which is 6 plus 4, which is 10. And that means that the coordinate 3, 10 would be a point on that function. This one up here also meant that the coordinate negative 2, 0 would be a point on that function. All right, so a function, you can read these down here. I just left these in your notes for some fill in the blanks, but a function is a relation in which every x value is paired with exactly one y value. Now, an example, a circle is not going to be a function because the x value, like for example, if you had a graph right here, this x value has two y values. And so since your x value is paired with more than one y value, that would make it not a function. Now, the test that you can do to determine if a relation is going to be a function or not is called your vertical line test. And so if you can draw a vertical line and make it cross your graph more than once, then your graph is not a function. The domain is going to be your set of x values, and your range are going to be your set of y values. We've discussed that before. And then we have discrete graphs and continuous graphs, and we have discussed those as well. So your discrete graph is going to be just simply a set of points. For example, if you had points graph like this, that would be considered a discrete graph. And if you had a graph that connected those points, that would be considered a continuous graph. All right, so now we're going to have what's called increasing and decreasing. and we're going to just put some letters on here. I'm going to use A, B, C, and D to represent the x values at these particular points. So when we talk about a function increasing, you're looking at reading your graph from left to right. And so we're reading the graph in this direction. Increasing, you're going to refer to the x values between which your graph is going up from left to right. So in this situation, your function is increasing from the x value of A to the x value of B union, and then your function is also increasing from your x value C to your x value D. So there are two sections here where your function is increasing or going up. And there is one section here where your function is going down, so your function would be decreasing from B to C. And there are no holes, asymptotes, or gaps in your graph when you're going to have a continuous graph. And a graph is increasing where it's going up from left to right, and decreasing where it's going down from left to right. And I'm going to have you use interval notation for those things. All right, so let's look at an example here. Domain of this graph would go from -2, which is right here. It's an open circle, so it's a parenthesis, it's not included. And then it goes to this x value over here, which is 4, closed circle, so it's a bracket because it is included. Your range is going to go from this y value, which is -4, and then goes all the way up to this y value, which is 3, included, so it's going to have a bracket. All right, so your function is increasing between here and here, which is from -2 to 0, but it's also increasing here from left to right, and so that is from 2 to 4. Increasing and decreasing is always going to be x values, and it's always going to be using parentheses. And this function is decreasing between the x values of 0 and 2. We do have a maximum value, that is the y value of 3. We have a minimum value, that is the y value of -4. Yes, this is a function, and we know it is a function because it passes the vertical line test. No matter where I draw a vertical line, it will only intersect that graph in one point. Therefore, it is a function, and the graph is continuous. All right, so this one, I'm going to have you do this one on your own, and then we're going to take a look at some of the examples here. Working on a little bit of algebra and arithmetic with these things. H of -1, once again, the -1 represents your x value, so everywhere you see x, you will replace it with -1. This is going to give you -3 times -1 squared plus 2. Now, you do need to remember PEMDAS, your order of operations, which means you do what's inside parentheses first, followed by exponents, multiplication and division from left to right, and then addition and subtraction is last from left to right. All right, so we do have an exponent here of 2, and we have multiplication in between this 3 and the parenthesis. So we need to take care of this exponent first. So that's going to give you negative 3 times, now negative 1 squared is negative 1 times negative 1, which is positive 1. And then that gives us negative 3 plus 2, which is negative 1. And you can do the same thing with this 4. Okay, so that would give you negative 3 times 4 squared plus 2, which is negative 3 times 16. That's negative 48 plus 2, because you do multiplication before addition. And then negative 48 plus 2 is negative 46. All right, so this time, this problem says that your h of x is negative 10. H of x is this value. So that means our equation would be negative 10 equals negative 3x squared plus 2. Now, when you are solving an equation, you are going to use PEMDAS, but you're going to use it in reverse. So our ultimate goal here is to solve for x. That means we need to get rid of this 2, we need to get rid of this negative 3, and you need to get rid of this 2, this square on this. So to move things from one side of your equation to the other, you do PEMDAS in reverse, so addition and subtraction stuff is going to move first. That means you're going to move this 2 over to the other side first by subtracting it, which will give you negative 12. Then in between here you have a multiplication, and then here you have a square. Well, doing PEMDAS in reverse, you do multiplication before exponents. So we're going to undo the multiplication by dividing by negative 3. Negative 12 divided by negative 3 is positive 4. And then your last step is to get rid of the square by taking the square root of 4. Now, any time that you take a square root of a number when solving an equation, you are going to put a plus or minus in front of that square root. And the square root of 4 is 2. What that means is that there are two possible solutions, because positive 2 squared will give you 4, but so will negative 2 squared. That will also give you positive 4. So there are two answers here. You must put that plus or minus in front of there. All right, so the next one, we're going to follow the same procedure. We're working with fractions this time. So you have 5/4 equals negative 3x squared plus 2. Now, anytime you have equations that have fractions, you can make your life a little bit easier by getting rid of the fractions by multiplying by your least common denominator, which in this case we only have one denominator, and that is 4. So multiplying by 4 times 5/4, the 4's will cancel. That just leaves you with 5. 4 times negative 3 would give you negative 12x squared. And then 4 times the 2 is 8. Now we have an equation that does not have any fractions, and we can solve using the same procedure we did before. So we're going to move the 8 over here first, and 5 minus 8 will give us a negative 3. Then you're going to divide by negative 12. Negative 3 divided by negative 12 is positive 3/12, or 1/4 when you reduce it. And then when you take the square root, once again, you're going to have a plus or minus square root of 1/4, which simply means when you take a square root of a fraction, you take the square root of the numerator over the square root of the denominator. So plus or minus 1/2 would be your solution here. Now these vertical bars simply mean absolute value. That means it takes whatever is inside and the absolute value bars and makes it positive. So when we substitute -3 in, you're going to get 2 times -3 minus 1, which is -6 minus 1. That gives us the absolute value of -7, which is 7. And 4 times 7 is 28. And you can do the same kind of thing with the 3/4. All right, so let's use this next function. We have c of t is equal to 2t cubed minus 3. So that means we're going to have 2 times 1/2 cubed minus 3. Now, 1/2 cubed means 1/2 times 1/2 times 1/2. It also means 1 to the 3rd power over 2 raised to the 3rd power. Well, 1 cubed is 1, 2 cubed is 8. Now that would give you 2/8 minus 3. Well, that happens to be 1/4 minus 3. And in order to subtract with fractions, you have to have a common denominator, which would be 4. So this becomes 1/4 minus 12/4, because 12/4 is equivalent to this 3. And then 1/4 minus 12/4 will give us -11/4 for an answer. And you can do the same kind of thing with the 5 for evaluating this. All right, let's come down here to the next one, where we have c of t is -19. Remember, c of t is your y value. And that's going to equal 2t cubed minus 3. So we're going to solve by adding 3 over to this side. -19 plus 3 is -16. We then divide by 2, which is -8. All right, so when you have something like t squared equals 9, you would solve by taking the square root of 9. So if we have t cubed, you are going to solve by taking the cube root of that number. Now when you take a square root, it means something times itself that will give you 9, which that answer is a 3 for your square root of 9. So a cube root means something multiplied by itself times itself again that will give you that -8. The value that does that is -2, which means the cube root of -8 is -2. All right, so this one's going to be involving some fractions, which is why I want to take care of working through this one with you. You're going to have -69 over 32 equals 2t cubed minus 3. So we are going to start by adding 3 over to this side. So that's going to give you -69 over 32 plus 3. Now, this could also be written as 3 over 1, which means we would have to have a common denominator. That common denominator is 32 because we're adding fractions. We've got to have common denominator. 3 is equivalent to 96 over 32. So that will equal our 2t cubed. All right, so when we add these two things together, that's going to give us 27 over 32 equals 2t cubed. Our next step is to divide by 2. Now when you divide by 2, that is the same thing as multiplying by 1/2. And it might be easier to think about it as multiplying by 1/2, because this 2 cancels with this one. And over here, you're just going to multiply these two fractions together, which will give you 27 over 64. And just like before, if it's a cube root, we solve by, or if it's a cube, we take the cube root of both sides. And the cube root of a fraction is the cube root of the numerator over the cube root of that denominator. The cube root of 27 is 3, because 3 times 3 times 3 gives you 27. And the cube root of 64 is 4, because 4 times 4 times 4 gives you 64. So 3/4 is our answer on this one. And when you're doing a cube root, you do not put a plus or minus in front of your answer. All right, let's take a look at this graph real quick. This says to use the graph to find the indicated information. Domain, all right, so that's our x values, goes between -4, which is included, so it's a bracket, up to +4, has an open circle, so it's not included. Range are your y values. The lowest y value is -3, and it goes up to the highest y value of 1, which also is included. All right, so your function is increasing here, and it's also increasing here. So it's really increasing from -4 to +2. There was no decreasing on that interval or constant on that interval at all. It's increasing that entire way. Two different rates of increase, but it's still increasing. Decreasing on the x values between 2 and 4. All right, the maximum value is 1. The minimum value is -3. Then remember, those are the y values. This is a continuous graph, and it is a function because it passes the vertical line test. No matter where you draw a vertical line, it is only going to intersect that graph once. All right, so now f of 1 this 1 refers to the x value. So what we are doing is looking at this graph at the x value of 1. Well, when the x value is 1, you follow that down to your graph. The y value there is -2, which means f of 1 is equal to -2, because f of 1 is a y value. The 1 by itself is the x value. So what this is asking for this one is, what is the y value when x is 3? So if you follow this over, when x is 3, that is the point on the function, and the y value right there is 0. And then the next one is asking, when the y value is equal to 1, what's the x value? All right, so you come over to your graph. Here's a y value of 1. Follow that over to your graph. That coordinate has a y value of 1, and its x value is 2. All right, and I'm going to leave the rest of these for you to work on your own.